we're going to get the same base on the right-hand side and the left-hand side. So for part A, I'm going to look at that one. Get this out of the way. And it says 3 to the x equals 81. Well, 3 is broken down as small as it can. Is 81 3 to the something? What? Okay, now when I get to here, did I just write that? Income. There we go. There's the x, sorry. Okay, so if your problem with these is, oh, but I didn't know that that was 3 to the 4, there's not a lot I can do for you. You know what I mean? I'm sorry, but I can't somehow magically get you to know those things that I wrote on that list. You kind of just have to know them. Okay? So 3 to the x equals 3 to the 4. Now, you don't cross those 3's out. You're not dividing by 3. But what you're saying is, if 3 to the x equals 3 to the 4th, then x has to be 4. Agreed? That's called equating the indices. Okay, so when I get the bases the same, I'm allowed to make the indices equal. Makes sense. Okay, B. Okay, I'm not sure if that's 4 to the something. I don't really know. Okay, so I could grab my calculator and say, all right, I'm doing these problems. Let's see, let's quit that. Let's see if, that's better. If that's 4 to the, I know it's not 4 squared. Is it 4 to the 3rd? Oops, I've just put L. Is it 4 to the 3rd? No. Is it 4 to the 4th? Yes. Okay, so I might have to do that. And so I write it out. I equate the bases. I'm going to do another little example right next to that. So I go x minus 1 equals 4. I'm equating the indices. So x is 5. Now, there are times when you have to fiddle with both sides. Like on this, I could have gone 4 is 2 squared. You agree? And 256 is 2 to the 8th. Right? So I could go 2 bracket x minus 1, I have to use those brackets, equals 8. And again, I just get the same thing. I know you wouldn't do this because it's harder, but sometimes you have to do it. I get the same thing. Okay, so as long as I get a base where they're the same, then that's okay. This is definitely the way to do this problem, but if you did it that way, it would be right. You want to ask a question right now? Okay, here we go. So I'm going to use these two index laws, and here I have not the same base. Can I get that to be the same base? Yeah. Okay, so I'm going to do that first. And I'm going to make sure that times doesn't look like an x. We just talked about it in the last problem, where when you have a power to a power here, you're going to have to use brackets around there or you're going to get the problem wrong. That's 125 to the negative 1. Do you agree? Okay, I'm going to do a little weed work over here. So 1 over 125 is 125 to the negative 1. Is that 5 to something?
Yes.
5 to the 3rd. So this is 5 to the negative 3. Everybody okay? All right. Now I need to use my rules. I'm multiplying like bases here. So the 5 stays. I don't put 25 there. I'm not multiplying 5 times 5. I couldn't do that because these are raised to powers. So I can't multiply them. I just add their indices. Okay, so I get 5 to the 3x plus, can I multiply that out, please? Expanding, I'm going to expand that. 8 minus 4x equals 5 to the negative 3. So I've done my trick where I have to get like bases, 5 to the something and 5 to the something. Whatever. Okay, I'm going to keep the 5, and I'm going to go negative x plus 8. What is that called when you do that algebra? What is it called? Yeah, it's collecting like terms, right? Okay. Now I'm very good. I can equate the indices. I'm just going to write that on this page again. Equate indices. And that can happen when I have 5 to the something and 5 to the something. I can't do it when I have 2 5s or a 5 and a 3 or whatever. But it's just one number to a power and that same number to a power, then I can write this down. All right, here I go. So I have in my brain, this is the hard part, I can see that and I can see that. I don't really care about any of the other numbers. They're not of any concern to me. Okay, but I can see these two things. And when I can see that I have a base raised to the 2x and the same base raised to the x, then I can use this substitution. And the substitution I'm going to use is that. And it's always the one I use. I let it equal this. And then I rewrite the equation and I say, okay, well, if u is 3 to the x, then 3 to the 2x is u squared. Okay, like if I square both these sides, I get u squared equals 3 to the power. To a power means multiply, yeah? So if u equals 3 to the x, then u squared is 3 to the 2x. So I can replace that. Then I put minus 6u minus 27 equals 0. So I've just, what I've done there is called reducing to a quadratic. Not reducing, reducing. Okay, I've reduced it to a quadratic. Now what do you reckon you do? Beautiful. Okay, I've got everything on one side equal to 0. Okay, so I reduce it to a quadratic, and then I want everything on one side equal to 0. Right, everything on one side equal to 0. And I might think of two things that multiply to give me negative 27 and add to give me 6, 9 and 3. Okay. U equals 9, or u equals negative 3. I'm going to get you all caught up to there. Okay, so this is what we did. I'll cover that up. We used our notes from the page before to say if 3 to the 2x and 3 to the x are both present, so same base, 1 2x, 1x, then I use this substitution, u equals 3 to the x. Then, if I square both sides, I get u squared equals 3 to the 2x. So I can put u squared there and u there. Then I recognized that I had everything on one side equal to 0, and I factorized. And I got my two answers, but then I said nobody wants u. And so I went to the pink, and I put 9 in for u, and I put negative 3 in for u, and I realized that I couldn't take 3 and raise it to a power. Somebody said maybe it could be x to the negative 1, but x to the negative 1 is 1/3, not negative 3. So nothing works there, so I rejected, and I got this answer. And then I actually plugged it into my calculator, the 2, for this, just to make sure it worked, and it did. Okay, the questions are on the next page.